Hi everybody. Well, today, by request, we're going to look at turnout controllers. So I'll show you in a second what we're going to be looking at. But anyway, we're going to go underneath the layout and see what's really hiding away down there, making those turnouts work. But first, a look here at the fascia. You see those unpainted knobs sticking out. Well, those are the turnout controls that we operate from. So they're just push-pull knobs, and today we're going to look at what they're connected to behind the fascia. And you can see they're all recessed in a counterbore, but that's not necessary. It's just kind of a cosmetic thing. So that's on the front of the layout, and we're going to be focused on that turnout right there today. It's kind of all by itself so we can get a good view of the mechanism. And then next thing, we're going to go under the layout and see what's down there. Alrighty, here we are under the layout. And in front of us there is the mechanism for that turnout that we looked at. We're using Blue Point switch controllers here. Of course, this blue thing is the Blue Point controller. And you can see it's got a control arm here that swivels. And of course, the actuator rod, I hope you can see it there in the video right there, going up to the points on the turnout. So it's fairly conventional in that regard, though of course it's manual by design. The Blue Point also has electrical contacts. It's got a double pole, double throw switch built in. And so the wires you see connected to it right here are of course feeding the frog on the turnout. So we've got the blue and red wires here connected to the track bus, the DCC track bus. And this black wire right here goes up to the frog in the turnout. So the frog is way down here, quite a ways away from the points, because it's a number 6 turnout, so it's kind of long. Now the mechanism as it was originally designed was intended to use a push-pull rod connecting it to the fascia. You see this red tubing right here. That's a little segment of the rod that came with the controller. And it fits into a clamp right there. And the other end is clamped into a clamp on the back side of the fascia. And then a flexible plastic rod runs inside that red tube to connect the button on the fascia to this part of the mechanism right there. Little clevis hooks onto that. And so the push-pull rod as designed would actuate this mechanism right there, just like that. After installing that and living with it for a while, I decided there was a better way. And that better way is to connect a dowel rod, like you see right here, directly to the throw bar, or the throwing arm on the controller right there, and do away with the push-pull tubes completely. So this is actually gone. And the camera lost control there for a second. So this little thing sticking out, which clamps the push-pull tube, it's just decorative now. It's not being used. So the Blue Point controller screws onto the road bed there, the sub-road bed, the same way a tortoise would. And if you look over here, you can see the rod comes in through a hole in the fascia right here and just extends straight out, connects directly to the actuating rod. There's a little tiny hook right there that screws on the end of the dowel and through a hole I drilled there in the actuating rod. So the actuation is very direct and it works really well. The problem I had with the original concept was I've got some turnouts real close to the fascia, and there wasn't room to get the push-pull rod in there. Because you see this mechanism sticks out several inches from the Blue Point. And that would have been right next to the fascia. Or anyway, it was too close. And that helped me decide to do a different way with the dowel rods. But I think they turned out better in any case. And I found out that using the dowel rods, they're not critical with respect to the alignment. A little bit of side-to-side alignment is okay. A little bit of up and down angling of the actuating rod works just fine. In fact, this other rod you can see in the video frame here, the upper one in your view, is a good example of that. That rod goes up, as you can see. It goes up here through a tunnel I basically built in the styrofoam scenery. And it goes up to a turnout that's on the back of the layout up on the upper level. And so the rod definitely is not level, but it works just fine, no problem. So pretty flexible system. And of course the dowel rods don't have any friction, and they work just fine. A direct mechanical connection to the actuator. So that's the basic story on the turnout mechanisms. And they're all working just fine. And finally, just for completeness, there's the other end of that dowel rod. Of course, the push-pull button here is just screwed onto the end of the dowel. That was a little dicey because I used a pretty small dowel. If I did it again, I'd use a bigger one. But drilling a hole in the end for the little tiny screw and then screwing it in without messing up the dowel rod. But anyway, it came out okay. And but I would use a bigger one next time. But anyway, it's working. So I think that completes the picture on the turnout controllers. As you can see, I've got labels on all of them, so I know which one is which. And that helps a little bit. So anyway, looking over now at the turnout itself, we can see it moving when I actuate it. So that now, I believe, completes the story.